Hi, my name is Brian Caffo, and this is Introduction to Regression. This class is co-taught by my co-instructors for the data science track, Jeff Leake and Roger Peng. We're all in the Department of Biostatistics at the Johns Hopkins Bloomberg School of Public Health. So let's talk about the kinds of questions that we're going to try to answer in this class. So the data that we're going to be looking at, in fact, let me go back to this previous page. There we go. The data we're going to be looking at is from this fellow right here, Francis Galton, who we'll talk a little bit about later, but he was a famous figure in statistics. And he developed the word and the concept regression. And what's interesting is that his data is still actually relevant. So one of the data sets that he used in developing regression was using parents' height to predict children's height. And in fact, there was this article not too long ago in the American Journal or the European Journal of Human Genetics that compared using genetic information to using Galton's Victorian era model, so I would suggest that you look at that paper. It's also a bit of a commentary on the utility of genetic information for predicting something as simple as height that's perceived at least to be mostly genetic. So at any rate, read that article, it's quite fun. But for our purposes, we're going to be talking not only about how can we use parents' height to predict children's height, so that's the example of one of the kinds of questions we'll answer, but we're going to have an entire class on prediction. And we're going to talk about modern prediction, high-dimensional predictors, complex interactions, very complex model spaces. So we'll actually talk a lot about prediction. So what I want to focus on this class is actually the second question, which is to find a parsimonious, easily described mean relationship between parents and children's heights. And what I mean by parsimonious is I mean sort of as simple as possible and no simpler, and interpretable. We want a simple, interpretable model to describe the relationship between parents' height and children's height. And that's what regression is really good at compared to, say, more modern machine learning algorithms. It gives you very interpretable models. We'll also talk about how do we quantify what we can't explain, residual variation. We'll talk about how we can take an alternate variable. Maybe we won't exactly do this example, but we'll talk about how we can use other variables and show how these other variables impact the utility of parents' height for predicting children's height and quantify the amount of variation explained by either. And we'll also figure out what assumptions are needed in order to try and generalize from not only the data that we have in hand, but to the population of parents and the population of children. And then there's this very interesting question, this very last question, which we'll have a lecture on just for fun, which is why is it that children of very tall parents, they tend to be tall, but a little bit shorter? So if you go, let's say, go to the NBA, which is the American National Basketball Association, and look at the players, look at their children. Their children tend to be tall, but not as tall as their parents, or even factoring the case that the spouse tends to be a lot shorter than the player, even factoring that in. And so why is that? Same thing is true for shorter parents. Their children tend to be short, but a little bit taller for very short parents. Seemingly paradoxically, why is it that parents of really tall children tend to be a little bit shorter? And why do parents of really short children tend to be a little bit taller? Okay, so that's this idea is regression to the mean, and we'll explore that because at first blush it seems a little bit counterintuitive.